Okay, so these problems here, the first four are pretty straightforward. There's not a whole lot to do to kind of get you into the idea or into the groove of what we need to do in order to prove these identities. Okay, so the key word here is prove. Prove this is true. Okay, so we have to do all the work in order to show that the left side, that if I took the sine of an angle and multiplied it by the secant of the same angle, that's the same as doing just the tangent of that angle. Okay, so this is what we're going to prove here by using our identities, by replacing trig words with their equivalents, right, with their identical things that help us to cancel things out or to change them in a way that will help us get towards our answer. Okay, and this is, of course, our answer. We want the answer to be tan. So remember, our number one strategy in all of this identity stuff is to replace everything with sine and cosine. Okay? So the thing that is not a sine, right here we have a sine, check, that's already sine. And then we have secant. So secant is not a sine or a cosine, but we do know, hopefully, that there is something that we can replace secant with that is a sine or a cosine. Okay, and that thing is one of the reciprocal identities. So hopefully you have the piece of paper, right? You've looked at it a couple of times and you know that the secant is equivalent to 1 over the cosine. Okay, the secant is the reciprocal of the cosine. So instead of having secant in our equation, we can write 1 over cosine because those two things are equivalent. The secant is the reciprocal of the cosine, which is 1 over. So now we have the sine times a fraction, right? So if you want to do fractional multiplication, we do top times top and bottom times bottom. So sine times 1 is just sine, and 1 times cosine is just cosine. Okay, so then this becomes our quotient, right? The sine divided by the cosine. And if we look into our chart, hopefully you know that the sine divided by the cosine is what single trig word? That is the tangent. The sine divided by the cosine is equivalent to the tangent. And guess what? That's exactly what we want our answer to be. So let's look at our second example here. We have the tangent squared times 1 plus the cotangent squared. And we're expecting that to equal the secant. Okay? So there's a couple ways that we could proceed here. Okay, a couple of ways. One way is to use algebra, and that would be to distribute tan squared into both of those terms, right? That is definitely one way to do it, and it's actually a pretty good way to do it. Okay, but just so you know, there's another way, and that would be using our Pythagorean identity to replace 1 plus cotangent squared. Right, so hopefully you can see the Pythagorean identities. 1 plus cotangent squared is the cosecant squared. Okay, that's one of your Pythagorean identities. So in this way, I'm replacing the whole 1 plus cotangent squared. Because notice in our answer, we don't want to have a plus or a minus. Right? There's no addition or subtraction over here. So we got to find a way to get rid of the addition problem. And this whole entire thing, 1 plus cotangent squared, is identical to cosecant squared. Okay, that's a Pythagorean identity. Now, we're going to go back to our number one strategy, and that's replacing things with sine and cosine. So what can we replace the tangent squared with in terms of sine and cosine? Yes, very good. Tangent is the sine squared over the cosine squared. And cosecant. I'm going to replace cosecant squared with its reciprocal. So the reciprocal of cosecant squared is 1 over the sine squared. Okay, so I am replacing my two trigs, my tan squared and my cosecant squared, using my number one strategy of replacing everything with their sine and cosine equivalent. So tan squared is sine squared over cosine squared. Cosecant squared is 1 over, right? That's the reciprocal. So now when I multiply these things together, hopefully you notice there's a sine in the numerator divided by sine in the denominator. Sine divided by sine is 1, right? So those will divide themselves out, and my simplified answer now is going to be 1 over cosine squared. Okay, so when I perform this division of sine squared divided by sine squared, I just get 1, right? 1 is in my numerator, and 1 over cosine squared. So then looking at, our answer wants to be secant squared. Well, hopefully you know that 1 over cosine squared is the reciprocal of secant squared. And that's exactly what we want our answer to be. So moving over to number 3, we have 1 minus cosine squared divided by the sine is supposed to be equal to the sine. Okay, so we are going to use the strategy of getting rid of subtraction if we can. So this whole entire problem, right, that whole entire thing, 1 minus the cosine squared, is part of a Pythagorean identity. Okay? And that is that 1 minus the cosine squared is equal to the sine squared, right? That comes from the cosine squared plus sine squared equals 1. So that is a manipulation of that Pythagorean identity. So we get sine squared over sine. Well, and then our brains need to think, what does it mean to square something? Squaring means multiplying it by itself. So sine squared is sine times sine. Okay, that's what it means to square something. It is to multiply it by itself. So now I have the opportunity to do some division. Okay, if I divide the sine by the sine, anything divided by itself is 1. Right, so that contributes a 1. Sine divided by sine is 1. And what's left in the numerator is sine. So 1 times sine is sine, and that's exactly what we want to do. Okay, so we are using our Pythagorean identity, and then we're using some basic algebra principles of squaring. What does it mean to square something? Well, that means to multiply it by itself. So one of the signs in the numerator cancels out with one of the signs in the denominator, and we're left with a sign from on top. Okay, hopefully we're getting the hang of this now. So number 4 asks us for some crazy things, right? It says, show that the sine squared equals 1 minus 1 over the secant. Okay, so we're going to manipulate sine in order to make it look like this. And we're using pretty much exactly what we did a second ago, right? We want to introduce a 1 minus something into our equation. Okay, we want to have a 1 minus, right? This is our goal. Well, because of that Pythagorean identity, I can replace sine squared with 1 minus cosine squared, right? That is a true Pythagorean identity. Sine squared plus cosine squared equals 1. So sine squared equals 1 minus cosine squared. I needed a 1 in my answer. I have a 1 in my answer. I need a minus sign in my answer. I have a minus sign in my answer. But now I need a 1 over secant, right? I need this fraction. Well, hopefully you know that the cosine is the reciprocal of the secant, right? So this is a reciprocal identity. We can replace cosine squared with 1 over secant squared. And you still have your 1 and your minus. And that is exactly what I want it to be. Okay? So when you're given the answer with these verified problems, we know what our answer needs to look like. So over here, we kind of have to introduce things to make it look like what we want to have it look like. Okay, so you're only working on the left side. We're not manipulating the right side at all. This is what we want it to look like, and we change the left side through identity manipulation, right? So this is a Pythagorean identity, and then this is a reciprocal identity. Okay, hopefully you have a chart that has all of these on there. There are many of them online that are available if you just search them up. Okay. Number 5. This problem says if I take the tangent of an angle and I add it to the cotangent, right? So we have a plus sign. We're adding two trigs together. That's the same as if I took my cosecant of the angle and multiplied it by the secant. So this problem is asking us to take addition and change it into multiplication. So let's see if we can do that. Now remember, our number one strategy is replace everything with sine and cosine. So we're going to replace tan with its sine and cosine equivalent. Okay, and these are the quotient identities. Tangent is the sine of the angle divided by the cosine of the angle. That's what our tan says, sine over cosine. And cotangent is the reciprocal of the tan. In other words, it is the cosine divided by the sine. So that is our number one strategy for all of identities, is replacing everything in terms of sine and cosine. So our tangent is sine over cosine, and our cotangent is cosine over sine. Now here, we've run into our 5th grade algebra problem. We have a fraction plus a fraction. What must be true if I want to add two fractions together? They have to have the same denominator. So we need to create two fractions with a common denominator. So on the right side, I need to multiply by cosine over cosine. Okay, because that's the denominator over here. So the left denominator, you multiply on the right side of your fraction. And the right denominator, which is sine, we multiply on the left side of my fraction. So I multiply the left one by sine over sine, and I multiply the right one by cosine over cosine. Right? This is doing the 5th grade algebra, or 5th grade fractional operations. You learn how to do fractional operations in 5th grade in America, and applying it to some trigonometry words. Right? But in essence, these are still just fractions, and we have to treat them as fractions. So now we go back to our algebra. We multiply sine times sine. That gets us sine squared. We multiply cosine times cosine. That gets us cosine squared. And now we can add these together because we have a single denominator of sine times cosine. Okay, which is fantastic. We no longer have an addition problem. Now we have a single fraction, which is sort of on the way to what we want the answer to be. Now our next step is to identify this very powerful Pythagorean identity. What does the sine squared plus the cosine squared always equal? Always equals 1. Okay, this is the Pythagorean identity. The sine squared plus the cosine squared equals 1. So if you're not familiar with that one, you need to become familiar with that one in a hurry, or these problems are going to be very difficult. Our denominator is still sine times cosine. So here's the neat part. What numbers multiply to give us 1? Well, 1 times 1 does, of course. So I'm going to replace this single one with 1 times 1. Right? Because my answer, I need to have two trigs. I need to have two trig words. 1 and 1. So now I'm going to split this into the product of two fractions. 1 over the sine times 1 over the cosine. Because that's still true. I can multiply two fractions together as a single fraction, or I can split them into the product of two fractions. And this is beneficial because 1 over the sine, well, that is the same thing as the cosecant, right? That's a reciprocal identity. 1 over the sine is the cosecant, and 1 over the cosine is also known as the secant. And that's exactly what I want my answer to be, cosecant times secant. Okay, let's check out our last one. We want to change our subtraction problem into a division problem. Cosecant minus sine needs to equal cotan over secant. Okay, so we're changing subtraction into division. All right, number one strategy, replace everything with its equivalent sine and cosine. Well, sine's already there. I don't have to change that one. But cosecant is the reciprocal 1 over sine. Okay, our number one strategy is to write everything in terms of sine and cosine. Now I'm back to the 5th grade. I have a fraction minus a non-fraction. So what do I have to do to my non-fraction in order to subtract it from a fraction? I have to change it into a fraction with the same denominator as my other fraction. So just like we did in number 5, I have to multiply this by sine over sine. I have to multiply that by sine over sine. Okay, so the long way would be to rewrite this as 1 over sine minus, now sine times sine is sine squared over sine. Okay, so I have taken my non-fraction, my normal sine, and I have written it as a fraction with the same denominator as my left fraction. Okay, this is 5th grade math with trig words which behave the same as normal numbers. 1 over sine minus sine squared over sine. Now that my denominators are the same, I can subtract my numerators. And since these aren't like terms, I can't really quote-unquote subtract them, so I just write them down next to each other. So my numerator becomes 1 minus sine squared over sine. So hopefully this is becoming recognizable. What do you recognize 1 minus sine squared as? That's your Pythagorean identity, and I can replace 1 minus sine squared with positive cosine squared. So here's my substitution part, right? This is a pre-calculus part, substituting with a trig identity. So now I have cosine squared over sine, which takes us back to problem number 3. What does it mean to square something? What does cosine squared mean? It means I multiply cosine by itself, right? Multiply cosine by itself. And I have one denominator of sine. Okay, well, this looks like it's a quotient identity, cosine divided by the sine. What can I replace cosine divided by sine with? Well, of course, I can replace that with cotan. And now that's cotangent times the cosine, right? Because it's cosine over 1. Well, cosine over 1 is just cosine. So I have cotangent times the cosine, which is pretty close, right? I needed to have a cotangent in my equation. Bam, I have cotan. But now I'm looking for a secant. Right? How am I going to introduce secant into my equation? Well, I know a little thing about cosine. and secant, right? There's a relationship between cosine and secant, isn't there? Yes, cosine is the reciprocal of the secant. Cosine is the same as 1 over secant. So I replace cosine with 1 over secant. I show that understanding that I am doing a reciprocal replacement. The cosine is 1 over the secant. And then I have, once again, fractional multiplication. If I do a non-fraction times a fraction, I put this over 1. Cotangent times 1 is just cotan. 1 times secant is just secant. And if we go back up to our beginning, well, that's exactly what we wanted it to be. Cotangent over secant. Check. So when we're doing these problems, we're combining all the things that we've done so far. We're doing our fractional operations, right? We're adding and subtracting fractions. We are doing our pre-calculus, which is replacing trigs with their identities. And then we're using the given answer in order to manipulate our left side in order to make the left side look exactly like the right side. Okay, and that's how we do it when we are verifying trig identities. Maybe you need some more practice. So find some more videos and practice some more.